Our last strategy that we'll use to solve a quadratic system of equations is to use substitution. And this process is the same as when we solved linear systems. We take something and plug it in for something else. So in this case, both of our equations are in y equals form. I can take this x plus 5 and plug it in right here, giving me the equation x plus 5 equals negative x squared minus 3x plus 10. And at this point you might think, oh, hey, this is a quadratic equation. Now all of a sudden I don't have y's here. This again gives us a quadratic equation that now we have all of these strategies that we can use to solve. So let's make our equation equal 0. Subtract x from both sides. Subtract 5 from both sides. And that gives me 0 equals negative x squared minus 4x minus 15. And I don't really like the fact that this is a negative 1 here. Okay, so what am I going to do to fix this? I am going to divide everything. Oh, goodness. This should be a plus 5. Whoops. Okay, that's a plus 5 here. I don't like that this is a negative 1x squared. So I'm going to divide both sides by negative 1, which gives me 0 equals 1x squared plus 4x minus 5. Looking at this equation, I have my a value is 1. This factors pretty easily. So factoring is my best strategy to solve. If I factor this, what numbers multiply to negative 5 and add up to positive 4? My factors would be x plus 5 and x minus 1. Leading me to my solutions to my quadratic equation. X equals negative 5 and x equals positive 1. But keep in mind that our solution to a system of equations is really where those two functions intersect. So not only do I care about the x value, I also need the y. So I need to take these x values and plug them in to find the y value. We get to choose where. It's going to be a lot easier to plug that x value into this bottom equation. Y equals x plus 5. Y equals x plus 5. Negative 5 plus 5 is 0. So my intersection point is negative 5, 0. And then plug 1 in. Y equals 1 plus 5. Y equals 6. My intersection point is 1, 6.